There may be times when you don't know the growth constant K, and you're going to have to solve for it. So let's say we have a problem where we say a bacteria colony follows an exponential growth model where the population doubles every 4 hours. Then if we double every 4 hours, then the amount that we're after is equal to 2 times the initial amount. So that's our new amount, right? We've doubled the initial amount. And we've said that this happens at t equals 4 because we're saying the population doubles every 4 hours. So what we really have is 2 times a sub 0 is equal to a sub 0 e to the k times 4. We don't know what the initial amount is. In this case, you can see it doesn't really matter. All we know is we've started with some initial amount, and 4 hours later, we have twice as much. And the reason it doesn't matter what that initial amount is because we can divide both sides by a sub 0, and that term goes away immediately. So 2 equals e to the 4k. Take the natural log of both sides. Natural log of 2 is equal to natural log of e to the 4k. The natural log of 2 then is equal to, since natural log and e are inverse functions, we just end up with 4k over here. And then all we have to do is divide by 4 to get k equals natural log of 2 over 4. And if we stick that in a calculator, we can see that that's approximately 0.1733. Now once we've solved for k and come up with an approximate value for it, we can fill in our model using that value of k. So we can say the model that represents this situation would be a of t is equal to a sub 0 e to the 0.1733 t. So given this model, which was based on the information that after 4 hours our population doubles, we could ask the question, how long will it take for the population to triple? In this case, we would just have 3 times the initial amount is equal to the initial amount times e to the 0.1733 t. And now we go through what's going to look like the same steps, because we cancel off the a sub zeros, leaving us with 3 equals e to the 0.1733 t. Take the natural log of both sides. Natural log and e are inverses, so we end up with natural log of 3 equals 0.1733 t. And then we divide by the 0.1733. So we see that t is equal to natural log of 3 over 0.1733. That's our exact value, and if we want an approximation, we stick it in a calculator and see that this is approximately 6.3394 hours.